Right, let's make a start. So, good afternoon,
Okay.
everyone. Welcome to the 102 stream. This is our third session of today, obviously the last day of the virtual conference. And we have Saurabh from BMC Software, and he's going to be delivering a session on mastering SQL performance on IBM Z. So, if you have any questions throughout, just pop them in the chat, and I can obviously let Saurabh know. But yeah, without further ado, I'll hand over to Saurabh. Thank you.
Yep. Thanks, Chris, and welcome everyone. Good morning, good afternoon, good evening, wherever you are. So let's get started. And my topic today is about SQL, basically SQL performance. So I'm expecting that, I will not be going too much into how to write a SQL, but how to write a better SQL so that it performs well. Uh, to set a context, why SQL performance is so important, because let me give you an example. Suppose you go uh, suppose you go to an ATM and you enter your debit card over there and you want to transact, you want to get some money from that ATM, and you enter your password and everything, but it is it gets hanged over there, and you are not able to take that money out at the time. It might take some time. It might get locked out, or it might get timed out. So half of the time, the reason could be that there is a very bad SQL running somewhere in the application on the mainframes on DB2 database, which took so much of time that it could not go back to the ATM and confirm that you are the right person and you need this much of money to be drawn. So very very small examples, but these SQLs which are running in different applications on mainframes affect at a very deeper level worldwide whenever we use banking or whenever we do any other stuff wherever there is a mainframe running in the background. So based on that, SQL performance is definitely something which is very important to do. And how to do it, let's dive in. I'm not sure your level of understanding on DB2 and SQL, but I'll try to make it interesting and put my point over here. So these are the folks who have created or developed SQL. SQL is called structured query language. It was developed mid-70s. It's quite before when DB2 was developed. DB2 was developed in 83, but SQL and then Oracle was developed in those times. So the mid-70s till late 70s were the time when RDBMS and all such kind of languages and databases were getting developed. So Donald D. Chamberlain and Raymond F. Boyce are the people. If you want to know more, you can just Google them or click it here on the Wikipedia link. So what are SQL queries? So if you see here, there is a person. It might be you, and you make a request, and that request goes directly to the database, and it fetches certain rows, put it in a table, and it brings back to you. It's very simple. Basically, a query is a request for the data which you are seeking for, or the information you want from that application from, and at the end it goes to a table or a combination of table. You can tell the database that what data you need, but you cannot tell him that how to get that data. So you do not have control on how to get that data back to you. So that is very important to know. It gets you data very easily, and you can write SQL in a very English-like syntax. So it makes it very useful and interesting. In terms of DB2, based on the red books which we have, the SQL reference guide says that a query specify a intermediate table or a result table uh, where it can be a subselect or a full select or a select statement. So subselect is basically a subset of full select, which is subset of select statement. So that's how IBM DB2 has arranged and configured these SQLs. The basic format of SQL you can see here. First, you have to write a select. which is the select clause. Then you have to write the from clause, select these columns from certain table. Then you put a where clause which does the filtering. You don't want everything to be selected, so you give some where clause. And then you do some processing. You can put an order by where it orders the rows in these columns order, and from ascending, or so here, like, you can mention if it is an ascending or descending. So it could be ASC or DSC. So you have an order by clause. You can have group by clause. You can have having clause, offset clause, fetch clause. There are so many clauses. Basically, when you combine all these clauses, you can get what you want from a table, or a combination of tables. And but the point is, you cannot tell that DB2 that how DB2 will fetch that data, and there you don't have too much of a control. But you can influence that. That's what we are going to learn. Here is another example where we are using max function and min function. Uh, Select job, max of salary, min of salary from employee table, and group by job. So you are getting for a particular job function, what is the max and minimum salary? So this is the query which you can run. Another example of group by, basically you are trying to get sales data on which week and on which day, which salesperson has done most of the sales. So you can group the output in terms of the sales date first, then the week of the sales first, and then after that the day of the week second, and then the salesperson. So that's the order of group by, and then you can order by, you can sort the data in that way. That's how output might look like. If you see the left hand side week, um, the week is all 13. The 13th week, there are 6th and 7th day of the week, these guys. And if you see, it's all sorted. So you can have a very formatted sort of data and you can create a lot of complex queries to get all these. Just to give you a brief to refresher to you, how the SQLs look like and what other stuff you can do. The full select generates the output table from one or more subselects. So you can create the subselects in the form what I have already shown to you. And then you can combine those subselects in the form of a union, like you have similar kind of selects from a table T1, then from T2, then T3, then T4, and then you can union it. You can run this operation of a union, and it will append data from each selects, and it will give you the combined data. Sometimes you need then except means it is an intersection. Sorry, it's a difference between two queries output. So that also you can get. Intersect means what is the common between two selects, that what you can get. Okay. Select statement as per DB2 guide. This is like you can mention after the declare cursor statement. So you invoke DB2 by exec SQL in a COBOL statement, and then you declare a cursor, then you open it, then you fetch the data row by row or in a group of rows, and then you close it. And you can, in between, you can process those data, you can send it to the host variables and all that sort of thing. Here is an example. Uh, this you can embed in a COBOL program. Exec SQL declare this cursor for this select, and this will fetch only first 5 rows. So this is how you can embed. So these are the different types of select statement. Now we'll see the method how you can invocate the SQL statements. One of the ways is you can embed in an application program, like what I have just shown you. You can mention it after the declare cursor statement, and it will be executed by the open command. So that's an static embedded program. Second one is dynamic, where you basically prepare the statement as they run. So there is a uh, processing happens whenever that program is called, which is called dynamic programs. Then there is something called as open database connectivity, ODBC function. You can do very similar stuff with that, but that's for the to connect with other databases. And then you can issue it interactively, like from a spoofy or from a batch job or any other stuff. So how can we measure how your SQL is doing? So as I said earlier, you can tell DB2 what data you want, but you cannot tell how you want it, because that is how the data will be accessed is basically done by DB2. Uh, but you can get a glimpse of how the data was accessed. And to get that glimpse, you need to understand what is an access path. So basically, access path is a data retrieval path. So it determines how efficiently data was fetched by DB2. It also gives you an understanding about how to optimize your queries. So once you understand the access path, you can, based on those inputs, you can optimize the query so that uh, the query runs uh, faster than what it used to run earlier. So the whole purpose here is to make it quicker, faster to fetch the same data. And also you can formulate the time when it was the access path was generated, either for a static program when you write a COBOL DB2, Java DB2 program, what was the time the access path was created. So for a static, you do a bind, and for the dynamic programs, it is determined at the runtime. As I said, you prepare the sequels at the runtime. So when I say DB2 decides, how to fetch your data, basically there is an engine inside DB2 which is called optimizer, and optimizer is the engine which determines how it is going to fetch, what is going to be the access path to fetch that data. What is the role of DB2 optimizer is basically analyzes your SQL. Also, there are some metadata to determine what is the most efficient path. So optimizer basically finalizes on multiple, it will get multiple access paths, and then it will choose the best one. It's part of relational data services, RDS. It evaluates the logic, the structure, the indexes, the statistics, the RTS, everything. And then based on that, it finalizes. How does optimizer think? I mean, how does it finalizes the access path? What is the best path to fetch the data required? So DB2 uses a cost-based optimizer. What this means is it's like you have 4 or 5 ways to fetch the same data. Obviously, you want one of the ways which consumes lesser cost. When I say lesser cost, that means how much CPU is being consumed, how many MSUs are being consumed. So it compares that, and based on that, DB2 optimizer retrieves the output. So that is one of the KPI. Yeah. So there will always be multiple access paths, and the optimizer selects what it thinks is the least costly access path. The decision is based on several factors, as we have already discussed, the tables involved and the data distribution statistics. So there, there could be multiple data distribution statistics, like for example, how many rows are there, number of rows, the cardinality of data, all that sort of stuff. It evaluates them, and these are one of the inputs on which basis it it finalizes the access path. Next is the volume of data. How much data is going to be returned? So suppose it has, the factor is, if you have 1 million rows in a table, and out of 1 million you just want 10 rows. So that is called the filter factor. So how much data, how much is the volume which you want, when you run a SQL? That is one of the inputs. The presence and structure of indexes and the clustering order. Indexes plays a vital role to influence your access paths. And indexes are a huge, big topic. You know, you have to definitely understand that, and based on how to create the best indexes based on your applications, and how to leverage your indexes in your applications. You know, that comes with the learning and with the experience. How efficient or inefficient your SQL code is, that is very important. The logic used in the where clause. So after where clause, you use columns and the predicates. Those influence, we will look into that. Those influence, those predicates which you use should be used very smartly. Otherwise, if if you misuse it, or if you use it not so smartly, yeah, your SQL might cost a lot to fetch the same data, same amount of data. The design, the overall application design, how the tables are being structured, are they normalized, denormalized, that also influences. So these are several factors which influence the optimizer's call to get the data and the finalizing the access path. Now we'll understand how to get that access path information. Now you have your applications which you want to be deployed in your prod systems, or they're already running there. So uh, you can always get that access path information. And for that, you have to run this explain utility, which is given by DB2. And this explain gives you an understanding of what access path was chosen by the optimizer. And it will also give you the estimated cost determined by the optimizer. It will tell you the cost as well. And to run and explain, the one thing which is required is called a plan table. So you need to make sure you have plan table set in your subsystems. That is the main important table if you want to understand the access path. Addition to plan table, there are many, many more tables which exist to give you more deep dive into the access path. Those are called the DSN tables, like DSN statement table or DSN function table. That also needs to be created to understand, to pinpoint the problem in your access path, if there is any. So what does a plan table contain? Uh, if you have any queries, just mind to put it in a chat, or if you want me to pause, and if you have anything to add, please interrupt me. So what does a plan table contain? So plan table, as I said, it's a table. It has multiple columns, and based on those columns values, you interpret the access path. So it contains like whether an index scan was used or a table scan was used, that you can determine. If a table space scan was used, then is it a full table space scan or a page range scan? So it determines that. Specific indexes, what are the indexes being chosen or not at all they have been chosen? How many of indexes and index columns being chosen in the access path? In which order they were chosen? What are the join method used? So, join is one of the functions which you can use to join multiple queries and fetch to write a complex query. So as the query becomes complex, the access path also becomes complexer. So uh, it becomes pretty hard to uh, analyze and then to tweak it. What else it contains? So it contains about the prefetch information. I think yes, Shayans. We can definitely check that there are catalog tables. You can check it from the catalog table. Okay, so whether prefetch is enabled or not. So prefetch is one of the ways where we will discuss more about prefetch later. So I'll skip this topic right now. Okay, any parallelism chosen? Any sort of is it using order by, group by, join, or distinct? So what happens is when you use these functions while writing an SQL, it basically triggers, it might trigger a sort of the data. So sorting is always a big problem. And if there is a huge chunk of data, and if it is sorting, that it is going to stall the processing for some time, and and it will drag the performance of your SQL. So always take care of these things. Locking strategy, you know that with in the SQL you can write with UR the uncommitted reads and in exclusive lock. So what type of locking strategy you are putting in your SQL? Other things, filtering, matching, correlation. So in addition, as you mentioned, what I just mentioned is just a glimpse of what you have in plan table. This is not the exact columns what I have. It's a big table, big table, cannot be discussed here. My whole purpose here is, to give you an uh, what you call the initial point from where you can go and explore. Text is available on IBM Redbook site and other sites. Basically, refer to Redbooks, and you will understand all the values in plan table, what are their meanings. Are what I just told you is the high level understanding of the key columns. But there are many more columns than those. Other than that, you have many DSN tables. Again, I'm not putting an exhausted list here, just to give you an idea about. Uh, sorry. Okay. So just to give you an idea about few of the key tables, like predicate table, it stores the detailed information about the predicates used in your query, each predicate. Uh, Filter table, so it captures the additional predicates and how the predicates are evaluated and filtered. So as I said, right, as you put 3 or 4 predicates, how much data is getting filtered? So you have 1 million rows in a table, but you are filtering 10 rows. So that is a very influential input parameter which is required during when you assess your access path. Statement table, so it provides the estimated cost to run the query. And the units are service units or milliseconds, so depending on configuration. Depth cost table, it holds the costing information in more detail, breaking down the different components of query execution cost. So these are some key tables, but there are quite more tables than these only. So again, as I said, you can execute and explain to get that access path information. So at your shop, you have already set plan table for you, all those DSN tables for you, any other configurations required. Now you can execute explains on different SQLs. Uh, you can do the explain statically from an application where you can run a bind, and in bind you can put explain yes, or you can do dynamically as well while running an SQL. In the beginning of your SQL, you can enable the explain. You can populate those explain tables dynamically as well. So there are different options for explain. Like if you mention about the statement cache, it will extract. These are for the dynamic application. It will extract the access path for the dynamic statement cache. You can get it there. Yeah, this is the option for bind rebind. And the rows will be either inserted to the package owner created plan table or the plan owner created plan table. If there are any aliases, then it will go there. For the dynamic SQLs, it is the current SQL ID. You can also do the remote binds, and you can explain via remote binds as well. Okay. So let's focus a bit on predicates. So I hope you understand what a predicate is. Predicate is an operator which you can put between columns or to a column after the where clause, or after when clause also. I mean, there are different clauses from where, basically after where clause. So you have subqueries, equal predicate, range predicates, in predicate, not predicate. These are the main operators. The last two pointers are what type of all these predicates are. We will dig deeper into that. So whether a predicate is indexable or non-indexable, whether a predicate can be processed at stage 1 or stage 2. So that you need to determine, and all these information you can get from plan table and other DSN tables. Let's focus on indexable and non-indexable. So indexable predicates, as the name suggests, can be used directly to probe and index and filter data via index. So if in your where clause you mention the columns from your index, and if the predicate is indexable, it will allow that index scan to happen. If the predicate is not indexable, although the column could be from an index, it will not be allowed. So that is very important to understand. If you have an indexable predicate, it will improve the performance. So, I mean, the basic point is if the predicate is indexable, it is good. It will perform better than non-indexable predicates. So first priority is indexable predicates. We don't want non-indexable predicates. These are some examples of indexable predicate: the equal predicate, the less than equal to, greater than equal to, between predicate, in predicate, like, and all these example is in front of you. These are just few examples. I have a exhausted list as well later. So if you have index on those columns, and if you're using these sort of indexable predicates in your query is definitely going to find the rows pretty quickly. It's going to be an faster query. Non-indexable predicate, I just said that I already mentioned. These are the reverse of indexable predicates. You cannot probe into the index directly by using those. It retrieves rows. So what it does is basically first the rows are retrieved, and then the filtering happens, which is not good. Some examples are like functions using upper, lower, something like that on your columns, arithmetic columns, uh, host variables in a different incompatible formats. If you in the like predicate, if you start with a wildcard, it becomes non-indexable. I mean, if you put the wildcard later, it is good. But you just start with wildcard, it is not good. The last example which I'm giving here. Now comes the stage 1 and stage 2 predicate. So stage 1 and stage 2 basically are the stages in the optimizer that, at what level the processing will happen when you inject a query in the optimizer. So these are the two different stages. So what is an stage 1 predicate? It is evaluated. This is very important to understand. It is evaluated during the data retrieval phase. When the data is retrieved, it is evaluated at that time. Like while you are scanning a table space pages, or while scanning an index, it is evaluated at that time when that initial processing is happening. So it is early in the processing stage. It is efficient than stage 2. So it is more efficient because the processing is happening early. Uh, all indexable predicates are stage 1, but not all stage 1 predicates are indexable. So all predicates which are stage 1 are indexable. That we need to understand. Here are some examples. Stage 2 predicates, as the data will be evaluated later in the process. It is not efficient because the processing, the predicates will be applied, once the data has been fetched, and then the filters will be applied. So it is later in the stage, which is not good. It creates an overhead on the processing. So it will lengthen the time of your SQL execution. Yeah, here are some example from Redbook. You can go and look into that and start using it. So these are evaluated. These are indexable and stage 1 predicates. Then you have stage one and non-indexable predicates. So stage one and indexable predicates are the best ones to use. Those should be used first. But if they have no choice, then go for stage one non-indexable. But it will not be as good as stage one indexable predicates. Stage two predicates are the worst ones. So this is the processing. Stage one predicate check. Comparison index uses direct filtering. If those match, you fetch the row. Once the row is out, stage two predicate check happens. Different functions, expression, you have complex queries, that happens. And then if those match, then you get the output result set. All right. So Chris, how much time we have? I will skip some slides if needed. I think. Okay, I'm not sure. I guess 15 minutes more left. Okay, so next part was to give you some example of uh, analyzing access path. So here is a very simple query. You all must be having this employee table in your DB2 subsystem provided by IBM, and you can populate that and run these queries and optimize the query and run access path. So this is a query where you're selecting these columns from employee table and you're putting in between predicate for employee number and a less than uh, predicate. There is no index. So if you see here, the access type is R. Whenever you see access type R, it says it means there is a table space scan happening and no index was chosen. Basically, there is no index, so no index was chosen. Match calls is zero because there are no indexes and no columns are matching, so it's zero. Access name is always the index name which gets chosen if there are any indexes, so it's blank. Prefetch is sequential. So also, also if the table is very small, it doesn't make sense to have an index over there. It's an overhead. So table space scan for a small table is good. But if the table grows, if you have millions of rows, then not good. Another example for the same query, now you have two indexes. The screenshot which I'm showing here from a SQL Monitor analysis tool. So don't worry, these are just the plant table and catalog table outputs here. You have two indexes, XMP1, P2, and these are the uh, output. These are the access path outputs. If you see, these predicates are applied, and employee number, which is part of first index, and salary also applied. Order first employee number was applied, then a salary was applied. The order number, the order is here 1, 2. You can see here there was a matching index happening on this employee number. Also, this one was salary. The filter factor says 98% of the rows were filtered, 96% of rows were filtered based on salary. This is more detailed. These are all the columns from plant table. If you see here, this is again not exhausted list, but these are again very important columns. You can calculate the cost of it. So cost calculation depends on a lot of other stuff which you need to configure at your shop. So don't worry about it. Then you have access type, which says index scan. Index scan means it is using the index match calls. One of the columns was matched. Is it an index only? Sometimes you can fetch your data from the index only. You don't have to go to the data pages or table space pages. So if that is the case, index only will be yes. Uh, then again, certain information. Prefetch, it is using list prefetch. Okay. Again, a different query. Both now the query has columns with very specific values with equal number. Now, if you see here, although there are two indexes, it has chosen table space scan because the table is very small and the filter factor is also very small. So stage one predicates very easy. So rather than going for an index, which could be an overhead, and there is a sequential prefetch applied as well. So uh, instead of going for matching index, it went for a table space scan. So these are the calls which DB2 optimizer takes, and it's totally up to the optimizer how it wants to access. It analyzes, compares, and then it uh, takes the call to have an optimal access path. So we'll go through and see some values in some key columns like access type. If access type can have values like IN, I1, N, MX, DX. So like if it has N, so N means in list have been used. So what happens if you mention an in list? The optimizer breaks it down to uh, equal or greater than or less than predicates based on the in list, and it rewrites those predicates in your for your query. So it has different implications for that. I1 means it's a one fetch index. One fetch index requires retrieval of only one row, and it is best possible access path which you can have. And if it applies only when you have aggregate functions like max or min used. So that is a very special case, and but that's a good access path which you want to have. If you have M means you have multiple index access processing, which has happened. Like MX means uh, there are multiple indexes, and then later some union or intersection has happened. If you have MU, yeah, here. If you have MU, then it is a union. I means intersection, and X means in general. It has used multiple indexes. There are different meanings of all these values in the column. How many index columns are matched? You can get it from the match calls. If it is no columns are matching, it is 0. One column is matching to 1, 2 matching 2. So more is merrier. So if the match calls have more number of columns to be matched, that means your access path is pretty good. Index only is quite good. Index, as I said earlier, index only column. That means it is not at all going, it is getting all the data required from the index pages itself. So that is great. Yeah. There is something called as direct row access. So you might know that there is a row ID, attached to the rows of the data pages. So if an application selects a row from a table which contains a row ID column, you can, set that up. The row ID value basically contains the location of the exact row which you want. And if you use that row ID value in your search, select delete or update DML. So the DB2 will have a direct access to that particular row, and it's good. So you can get that information from this column. There are some related columns as well, but this is the basic columns which you can get primary access type. How can you make how a potentially costly operation could happen uh, if you analyze your SQL? One of the thing is materialization of your views or nested tables. So by materialization, what I mean is you run a view and it gets materialized as a table, and you get another row in your plan table, and uh, it is an extra overhead, so not so good. Um, how the scan is happening? Is it happening on the whole table space, or it is happening on the specific partitions? So that makes a difference to the cost. What type of prefetch is used? Dynamic sequential list. Um, is a parallelism used? So DB2 sometimes uses for some cases, it can execute, it can analyze, different sections of your query in parallel, and that can uh, that can create. It's good if the parallelism is there. That's good. That means the processing happening in parallel. So you can get that data from this column. Sort, is it's sort happening or not? No sort is good, but if sort is happening, you have to look into that. Sort is not good. If the sort is bigger, it's not good. The subqueries are the getting set transform into a join. Look into that. What type of aggregate functions being used? You can get it from here. So when you create a trigger, while creating that trigger, and when that gets triggered in the when clause, it will, and if that SQL runs, you will get that query block time as trigger. So if you have to look into that as well, into the complex triggers. Okay, so this is a logical midpoint, and I think we are on time. Or Chris, how much time is left for me?
You've got a
Not
couple of
sure if
minutes
you
left.
couple of minutes left.
Have
Okay.
a quick scan of the chat, see if there's any new questions. Just
Yeah.
what that I can see. Um, but yeah, you got a couple of minutes.
Okay. Okay. So yeah, I'll skip a lot of these stuff. What I'll say, I think I am at the midpoint, or I have a lot of different concepts. So I came to a middle point where we analyze a lot of things. Mm, but I will quickly, take a minute or two just to glance it through. So I'll not explain these things, but I'll put these keywords in your mind so that you can go and you look into that. Like, for example, get pages. So you can go ahead and check about, because these are very important statistics and inputs which you need while analyzing your SQL. So get pages is one of the things which you need to understand how you have to. There was an example I wanted to share, but it's done. Then understanding the index pages, and uh, the leaf pages, non-leaf pages, what is the height of your index, how many leaf pages and non-leaf pages there is, the index splitting is happening, all that sort of analysis. That's what I'm telling the next level when you deep dive and analyze your SQLs. There are certain ways to avoid more get pages. So there were some examples I wanted to show, but I'll quickly complete that. Then another concept, another pointer which you have to always keep in mind is IOs. So how many IOs are happening? Are the IOs are happening more? So that you need to consider, because more IOs means more CPUs. Lesser IOs, lesser CPUs. Prefetch, which I mentioned about it. So prefetch is basically where what DB2 does is it prefetches, it expects certain pages which are going to be fetched later based on the application, and then it prefetches it into the pool, buffer pool, and the data access doesn't have to make an IO to fetch that data. So prefetching always makes SQL very fast. So is it happening? Prefetch is good. What type of prefetch? We have seen sequential, dynamic, and list. So I'll not go into the detail, but these are the pointers which you have to look into. Final slide. Uh, this is how the applications work. And the DB1 address space basically takes care of all these spaces. And you have the SQL interface where all the applications always go and make and get page request. And these get page requests can go to buffer pools or make an IO to the index pages or tables pages. So all this processing happens. These are very complex things, which once you start from the beginning and then you further move and understand all these deeper topics. This is a huge topic, very, very big topic, and cannot be covered in 45 minutes. But I wanted to give you some glimpses, some topics, some keywords, so that you can go and search about it, and might be at your shop at your shop, go and execute certain SQLs and explain, run those explains and get the access path. So the whole purpose is to put certain keywords and certain concepts in your mind so that you can go further and analyze it at your shop and read it. It's a big, huge topic, and every year it gets better. And IBM is doing a lot of stuff to make it perform better SQL. So I think, Chris, I'm done from my side. I quickly covered it at the end. Well, yeah, slide will be uploaded. Yes, I'll upload it.
That's brilliant. I really appreciate your time, Sarab. Let's just give it another moment or so just to see if anyone's got any other questions. But yeah, please do leave feedback. It is really well received by the speakers. Obviously, allows us to make improvements and see what we're doing well as well. Um, so yeah, that'd be really appreciated if you could leave some feedback. But
Yeah.
yeah, again, thank you for your time, Sarab. I really appreciate it. It's a really good session, and I think we've got two more sessions this afternoon. Obviously, then that finishes off the virtual conference this year, and obviously we've got the physical one in person, usually at Whittlebury Hall, later on in the year, which will be great. So hopefully see some of you there as well. Uh,
Yeah. And
yeah, sorry, go ahead.
sorry, I was just saying, yeah, like if you are, I'm always happy to connect with you on LinkedIn. So yeah, please connect with me on LinkedIn as well. We can chat later as well if you have any queries.
Any questions? Obviously, yeah, do feel free to
Yep.
reach. It looks like Sarab's just put a link in the chat. So if anyone wants to connect with Sarab, you can obviously yeah, connect and ask any further questions offline. But yeah, I'm happy to wrap it up. But again, thank you for your time and thank you everyone for tuning in. I really appreciate it. Obviously, these sessions are recorded, so you can come back to them once they're up on the site, and the presentation and the slides will be there as well. Thanks again, everyone. Appreciate your time, Sarab. Take care.
Thanks, Chris. Thanks, everyone. Have a nice day.